Hello. Yeah. Good evening, everyone. Yeah. Please switch off your microphone. Please turn off your microphone. I can't hear anything. Yes. 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 Please ask. Okay. 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 It's okay. So please turn off your microphone. So hi everyone. Good evening. So I am Subhanu. So I am a PhD scholar at IIT Delhi. So we'll be starting our week six tutorial uh, of this course operating system. So today our topic is first first some give me a second. So first some of the slides we will be seeing about the shortage job first, which is the last week we have seen the uh, FCFS fast come fast serve scheduling. So we are basically please Oshin Gupta, please turn off your microphone, please. Please start off your microphone. Yeah. So last week we have seen the fast come fast serve in the operating system chapter. So we are basically in the chapter of process management, as you know. So in process management, we have seen the attributes of a process, the states of a process. Then we have seen what is degree of multi-programming. So we can run multiple program within a single CPU. Then we are learning about some scheduling algorithms. So, so as a fast scheduling algorithm, we have already seen the fast come, fast serve scheduling algorithm. And we also know about what is the arrival time, bus time, and completion time, turnaround time, waiting time, response time from the previous class. So I will not be repeating that part. So I'll be starting our lecture today from the shortest job fast algorithm. Okay. Yeah. Shortest job fast, or we call it at SJF. Okay, so the also there is one thing that is which is also called shortest job next. Okay, so the algorithm is intuitive from the nomenclature of the algorithm. That is what the algorithm is doing basically. So suppose okay, so what is the criteria of this shortest? Okay, so criteria, so one thing that is shortest job fast. So what is short in all of the things? So the shortest part is the pass time. Okay, and what is the mode of this algorithm? So we have seen that is preemptive and non-preemptive type scheduling algorithm. Okay, preemptive means that suppose one job is running, and then so it will wait for some time, then another job will run. So it is not that type. So one whenever it will go to the CPU, it runs fully, then another job can get a chance for running. Okay, okay. How this happens basically? So we have an example of this. Like you have to find out the shortest job first, or what I can do, I can give ones from my side. Okay, okay, give me a second. Different. I think this 10. This is 10. So process number. So we have five process. One, two, three, four, five. Okay. So this is your arrival time. This is your bus time, and this is your completion time. Okay. So it is arrival time is given as 1, 2, 3, 4, 5. Okay. Nothing. I have changed nothing. Now bus time is 7, 5, 1, 2, 8. Fine. So this is given. So now you have to find the question in exam will come like find out the average turnaround time or find out the average waiting time. Okay, so we have example here. So I will first uh, take some time to solve this example. Then it's your job to solve the next example. Okay, fine. So okay, see. So how do we do this? So okay, so as you see that from zero we are starting, but from zero to one there is no process. So at time instance zero there is no process is coming. Okay, so at time instance one t is equal to one, the process number one has arrived. Okay, fine. So what we do that what is the bus time of this process? So at time instance one we don't have any other processes. So for from time instance one to time instance 7 because bus time is 7. Okay, so here I will have p1. So 7 plus 1 which is 8. Fine. Now this is done. Okay, so now what is the time? So t is equal to 8 now. So you can see that all these processes has arrived within time instance 8. Fine. So what you will do? What is your algorithm? Your algorithm is your job is to choose the shortest job first. Okay. So now you will choose the shortest one. So among all these algorithm, which is the shortest one based on the bus time? So you can see your your bus time is 5, 1, 2, and 8. 5, 1, 2, 8. Which is the shortest one? So what is the shortest one? The shortest one is the 1. Okay. So this is the shortest bus time. So now your P3. Now you will your P3 will run. So how long it will run? It will run for one time instead. So it will be 9. Then so this is done and this is also done. Now what remains? Remaining are this 5 to 8. So among 5 to 8, which one is the shortest? 2. Okay, 2 is the shortest one. So we will be so for this which process is this? This is P4. So we'll run P4. Okay. So how long it will run? It will run for 2 time instance. So 9 plus 2, 11. Now then 5. 5 and 8 are remaining. So 5 is the shortest one. P2. P2 will be here. So how long? It will be run for 5 time instance. So it will be 11 plus 5, what is 16. Now only last one is remaining, which is P5. For P5, it will be 16 plus 18, 24. Okay, fine. It is up to this is fine. Yeah. Hi, Diksha and Satta. Ha, ha, ha. So it's fine. So we will be we'll be solving the question and we'll be trying to find the average turnaround time or average waiting time. So if you can find out average turnaround time and average waiting time before me, then write the answer in the chat box. Okay. So now we know. So this is CT, turnaround time and waiting time. Okay. So what is the completion time of process 1? Which is 8. Process 2, which is 16. Got it? So from here, so I am writing here. So this is process 2, 16. 16 I am writing as a completion time. Fine. So I think we should not question on this. So now 9. 11, 29. Sorry, 24. 24. So what is the turnaround time? I have shown in the previous class turnaround time is the CT minus AT. Okay, CT minus AT. You already know it. TAT is equal to CT minus AT. Okay, and what is the waiting time? Waiting time is equal to TAT minus DT. Fine. So what will be TAT, CT minus AT, which is 7, 14, 6, 11 minus 4, 7, 24 minus 5, 19. Got it? Now waiting time. What is the waiting time? Waiting time will be uh, BT minus WT. Okay, TAT, sorry, TAT minus BT. Okay, I have written the formula here. Okay, so which is 7 minus 7, which is 0, 14 minus 5, which is 9, 6 minus 1, 5, 7 minus 2, 5, then 19 minus 8, 11. Okay, fine. Now you have to, your job is to find the average TAT or average waiting time. Hi, so Oshin Gupta Om Prakash, your question are, hi sir, please suggest what would be the exam pattern and the book to study. Okay, uh, I don't think that you really need a book for study. So if you need a book, then there is a book called Galpin. So uh, so just type that operating system concept by yeah. So it's a very popular book. There is only one book I have already. Uh, yeah. So this is called Book is Operating System Concepts. Yeah, by Galvin. So if you search this in the Google, then you can find the PDF already present in the Google. So you can download this and read this. But this is a very book. And I don't think that you will be able to read all of that. So my suggestion is that be question specific. The question from the previous assignment, your assignment, whatever, what type of question uh, you are solving, you are getting in your assignments and quizzes to solve that type of questions. Okay, so I think then you can easily pass the exam. Yeah. So how to get maximum score in the final exam? Hi, Om Prakash. So if you read maximum time, if you give your maximum time in for this exam, then you will definitely get maximum score in the final exam. Okay. It will only contain MCQ. So I am not sure about that. So I really don't aware about the examination, like the exam patterns. I don't have access to the question. Yeah. No, this is not Macro Hill. So this is Willy, I think. Yeah. So please search in the Google that operating system Galpin. That's it. Okay. So next thing that okay, now you have seen that Diksha and Satta. So then give me the answer of the average waiting time of the and average turnaround time. So please write that in the chat box. Okay, for this. Okay, so and another question for you guys also, that how this is implemented in the real life scenario, that how one job will come, then we'll find out the shortest last time one. So can anyone tell me so the question from here, it is the what data structure is used in the shortest job first algorithm. So what will be the answer for this? Yes, you can get the maximum score in final exam after reading the assignments and also live assignment. Yeah. Do try to practice same type of question you are getting in the assignments and also which are being solved in the video lecture of Professor something. Yeah. Yeah. Can anyone tell me that? So Prakash, do you know that what type of data structure it will be? It's used in the shortest of first algorithm. Okay, so we'll not will not spend much time on it. So I'll be telling you the answer. That I assume that you all know about the heap data structure. Okay, so there are two type of heap. One is mean heap and one is max heap. So here we are using the mean heap concept because in mean heap sorry in mean heap the concept is sorry if you are getting a always in the root your you will have the minimum value. Okay, so whenever you have a you are getting a bus time, you are getting a process with bus time 7 maybe. So where will you keep it? So basically you will keep it here first, then you will be comparing with your parent that 7 is greater than 5 or not. Yes, it is greater than 15 is greater than 7. So it will change. So 15 will come here and 7 will go here. Then again 7 and 10 will be compared. Then 7 will go here and 10 will come here. So 7 will be here. Okay. So this is the concept of mean heap. And using this mean heap, so you will be always keep track of the root element which is the minimum one. Okay, so mean heap will be used. So this is a important question for your exam also. So this is the mean heap is used for the shortage of first algorithm. Okay, and another thing also, so what is the time complexity? So this type of question it can definitely come. What is the time complexity? So So it is basically order of n log n because of the mean heap operation. Okay. So for getting the shortest element, so you know about the data structure and algorithm, right? So in the algorithm chapter, if you know if you have done the algorithm course, you know that finding or sorting any sequence of array, you would need order of. Are you giving me the question, Hanuman Prasad? Hanuman, are you giving me the question to solve it? Okay. So to become this heap, a minimum mean heap one, you need order of n log n time. Okay, so the time complexity of S shape is the n log n. Okay, so fine. Hmm. Now there are some advantages and disadvantages of S shape algorithm. Will we see that one by one? Hi Hanuman. So what is your what is the reason? for you to copy and paste this question in the chat box. Can you please explain? So I have written that that is maximum throughput. But what is the throughput? Throughput is the number of process by total time taken to finish all jobs. Okay. Okay. Now second is minimum average wait time and response time. Okay. So disadvantages is the starvation. I'll come to that point. What is starvation? And uh, and also if you see that this is not a real time algorithm, so you can't really solve this. You can't really solve the algorithm uh, in real time because you can't know the bus time beforehand. Okay, Hanuman, can you please? Okay, what I was saying. Yeah. So Hanuman, can you please turn on your microphone and tell me? Okay. So as you are not turning off your mic and telling me, so I will not be able to solve your question. Okay, fine. So I think I have already solved a question on the shortest of fast process. So this is I have already letting you know how this is happening. So this is very simple, very simple. So you should be able to do that. Yeah. Okay. Now, uh, okay. So as it is not possible because you cannot know the bus time beforehand. Okay. Okay. So this is not a this cannot be a doable thing. Okay. So then what can be done? So first thing is that what type of processes are there? So see a real life example like process type. You know there are two type of process. One is operating systems process and user process. So user process are like it takes 3 to 5 units of time. Okay, and process are of also various kind. One is interactive. Suppose you are typing something, so you will be giving your input. Then you will also. Why do we don't consider arrival time is shortest time first, and to consider arrival time in shortest remaining time first? Disha, your question is not clear. So, if you is it possible for you to turn on your mic and tell me? Mm-hmm. Mm-hmm. Yes, yes. Mm-hmm. 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 Yeah, yeah, yeah. So uh, the thing is, suppose in this scenario we can see that, so for the first P1, so P1 is done. P1 for P1 bus time is 7. Okay, so it has been done within 8. T is equal to 8. Okay, fine. So you can see within T is equal to 8, all processes has already arrived. Fine. So now, as so in your queue, so you have a queue. Okay, so in that queue your all processes has arrived. So what you will do with their arrival time then? Is it clear? So then you will be considering the bus time only. Got it? Is it clear for you? Yes. Yeah. So what is happening here, that uh, processes are coming. So this process, this P1, so this is P1. Okay, this is P2, P3, P4, P5. So P1 is coming at T is equal to 1. So we are starting from 0. So 0 to 1, I don't have any process to run. Okay. Now at T is equal to 1, okay, at T is equal to 1, P1 has arrived. Okay. Now it will run for 7. Bus time is 7. So it has run for 1 plus 7, which is 8. Fine. So now what is your time? Your time is 8. Okay. So within 8, you can see that P2's arrival time is 2, P3's arrival time is 3, P4's 4, 5. So they are all less than 8. Okay. So within this 8 time instance, all processes has already arrived. Hmm. Mhm. Okay. Oh, okay. Yeah. I got it. I got it. I got it. I got it. Okay. Let me see. So it was like, okay. Let us do that. Do the do that problem also. That how they are doing. So their process was uh, process number. So 80 PT. Okay. So P1, P2, P3, P4. So it is 0, 2, 4, 5. Their bus time is 6, 8, 7, 3. Is this problem you are talking about? Yeah. So we have to do the shortest job first. Okay. So at time instance 0, we have process P1. P1 has arrived. It will run for 6 time instead. So it will be 6. Okay. Now within 6, all has arrived. 2, 4, 5, all has arrived. Okay. Within 6. Now what I'll do, I have all the processes to run. Okay. So my algorithm will choose the shortest bus time first. Okay. Which is P4. P4, how long it will run? It will run for 3 time instance. So 6 plus 3, which is 9. Fine. That is done. Now, this is also done. Now I have 7 and 8. So I'll choose the 7 one because shortest job first. So 7, it will do for 16. Then P2, P2 will be 16 plus 18, 24. So this should be the Gantt chart for you. P1, P4, P3, P2. Okay. So maybe they have, I don't know. I don't know. Average waiting time is, so how do we do C AT, CT, TAT, WT? So what we do, we'll go in this way only. CT is BT minus AT, which is 6. Oh, CT we have, sorry. CT is P1 for 6, P4 9, P3 16, P2 24. So TAT is CT minus AT, which is 6 minus 0, 6, 22, 12, 9 minus 5, 4. Okay. WT is TAT minus BT, 6 minus 6, 0, 22, 8, 14, 12 minus 7, 5, 4 minus 3, 1. So what is the total? 5.6, 20 is the total, 20 by 4. 5 should be the average waiting time. I don't know. I have not checked the lecture, so this should be the average waiting time. Fine? Mm-hmm. Mm-hmm. Mm. This should be the answer here. Mm, uh, I don't know. Okay, okay. You can write those na in the feedback form. So you have a you always you there is a feedback form now. So please write that in that feedback form. Okay, okay. Thanks a lot. Hmm. Okay, okay. So one concept that will come in our question, so which is not, yeah. So you have seen that here I have some interactive process, I have some foreground process, and I have some background process. Okay, so interactive process like gaming. Okay, so in game you give some input with your hand or touch. So it takes like 5 to 8. Foreground process like 10 to 15, and background process like 15 to 20. So I am talking about the time instances. Okay, so now there are two, three concepts are here. One is simple averaging. So yeah, so these are the so this is a static process size. Okay, fine. Now if you have dynamic, so सर आपने वो अपना अटैकिंग वाला भेजा नहीं. हाँ कोई बात नहीं, मैं संडे को ही करूँगा. Okay, so this is the thing. Now the exponential averaging or aging is alpha into Tn plus 1 minus alpha into Tn. Okay, so this is how you will be determining the next CPU bus time. Okay, so you know that, so your process, so there are two types of things. So I have why we are discussing this thing, that in shortage of fast we have seen that we are sorting the we are choosing the processes based on their next bus time. But how bus time is how long the process will run. So this is not possible for anything that to know that how long the process will run. To overcome this issue, we have some techniques. So which one is start? We have some static process. We have some dynamic process. So static process is like process type. Like there are, you know, that what kind of process are running. So this is based on your previous experience. Okay, which is there are operating system process and user process, and interactive process, foreground process, and background process. So based on the process type, you know beforehand from your experience that how what is the size, what will be the size of the process. So based on what will be the size of the process, you can you can basically predict what will be the average runtime or burst time of the process. So you know that for a operating system process, the process can run for 3 to 5 minutes of time. For a gaming kind of interactive process, it is a 5 to 8 timing space. Okay. So now, as they have these are the static processes. So all processes are not static type. Okay, they could be dynamic type of processes also. So there are two concept came, which is simple averaging. So if you have n processes given, you want to pn, what you do, you you have already done some of those processes. Okay, already done something. So you know the bus time of the value. So Tn plus 1 is that 1 by n into sigma Ti. So this is the sigma Ti means the T1 plus T2 plus T3 plus like this. Okay, so you just add all of them and just just divide it by n number of processes. And what is the simple average or aging? Aging says that Tn plus 1 will be will depend on tau n and Tn. Okay, what is tau n? Tau n. So what you are doing basically, and this alpha is called the smoothing factor. So what will be tau n? Tau n is alpha Tn minus 1. So time taken to run the process which ran on in Tn minus 1 time, and 1 minus alpha into tau n minus 1. Got it? So this is how you will be starting the thing. Okay. So now so if you know what is the in Tn plus 1, if you put this value here, what you will get? You will get Tn plus 1 minus alpha into alpha Tn minus 1 plus 1 minus alpha whole square into tau n minus 1. Fine. Okay. So how this helps basically? So this helps on, like, so you are given that your alpha is equal to 0.5 and tau 1 is given, okay, 10. So actual burst time is like T1, T2, T3, T4 is equal to like 4, 8, 6, 7. Then your question will come like, what is find T5? So this is how your question will come in the examination. So alpha will be given, T1 is be given, actual burst time of T1, T4 is given. Now we will be finding the tau 5. Okay, tau 5 is the exponential average. So what is the exponential average? So you will be finding the length of the next CPU burst. So you will be finding the tau 5 CPU burst time at T5. Okay, got it? Now how will you calculate it? We'll write the you know the formula, tau 2 is equal to alpha into T1 plus 1 minus alpha into tau 1. Tau 3 is equal to alpha into T2 plus 1 minus alpha into tau 2, like this. So now tau 4 is equal to alpha into T3 plus 1 minus alpha into tau 3. This is very simple. Like what I am doing, like this, if this is 4, I am writing 3 here. So if this is 4, I am writing 3 here. So this is very simple. Tau 5 is equal to alpha into T4 plus 1 minus alpha into tau 4. Fine. So for the first one, you know, alpha is given 0.5 here. T1 is given, T1 how much? 4. Okay. 0.5 into 4 plus 0.5 into 10, which is 7. So you know the 7. So which you will put it, yes, which you will put here. Okay. Then you will get 7.5, then 6.75, then 6.87. So this is how we will solve the answer. Okay, fine. So now try to solve this one. So this is a question from your previous assignments. So please solve the question and try to write your answer in the chat box. Okay. So, did you able to solve the question? So, what is the, so this is the shortest job first. So, determine the average turnaround time. So, you know that AT, BT, I have CT, TAT, and WT. Okay. So, I'll try to write it my own. Okay. So, P, P1, P2, P3, P4. And AT is 2516. 2510. So VT is 62638. So it will be the CT. So we will be drawing the Gantt chart. So how we are doing it? Yeah. So let me solve. I'll tell you. Yeah. How will we solve it? So 80 is so on time 0, P4 is coming and it will run for 3 time space. Okay. At time 0, P4 is coming and it will run for 3 time space. Okay. So this is done. Now at time within time 3, 1 process 3 and process 1 has arrived. Okay. So between process 1 and process 3, the minimum bus time is for process 1. So that is 6. So which is 9. So this is done. Now within 9 all has arrived. 5 and 1 all has arrived. So 2 and 8 is remaining. So within 2 and 8, 2 is minimum. So we'll run P2 which is run for 11. Then P3 which will run for 8. Which is 19. Okay. So we'll write this one. CT is for P1, CT is 9. For P2, CP is 11. For P3, CP is 19. For P4, CP is 3. Yeah. Now the TAT is equal to CT minus 80, which is 7, 11 minus by 6, 19 minus by 19, then 3 minus 0, 3. WT is TAT minus BT, which is 1, 6 minus 2, 4, 18 minus 18, 3 minus 3, 0. Okay. So now we have to find the average turnaround time. Average TAT. Average TAT is equal to 7, 6, 18, 3. Add this one 7 plus 6 plus 18 plus 3 by number of process, which is 4. So 34 by 4, which should come, which should come 8.5. 8.5 is the right answer. Fine. Yeah, that's the right. Yeah. So another thing is, yeah, find the, for the same thing, find the okay, now for the same process scheduling using the SRTF, shortest remaining time first process scheduling, find the average waiting time. So this is not SJ, this is SRTF. Okay. So you know the process P1, sorry, P1, fine. So now find out the average waiting time. So what is the SRTF, shortest eventing time pass? This is the SGF with preemptive. Okay, so preemptive means suppose you are running a process. So you are running at time 0, you already have process P4. Okay, P4 has arrived, time 0. So you are running P4. Okay, but how long you will run? Then you see that at time instance 1, P3 has arrived. Okay, so and its burst time is 8. So will we stop it? No, we will not stop it. Okay. Oh, I have mistaken one thing. So this will be 0, 1, 2, 3. Yeah. Uh, yeah, Satta, who will decide the bus time? So your scheduler will decide the bus time. So I have told you that two things that bus time using this algorithm is not like it is not possible in the real life scenario because that we can't know the bus time in previous up beforehand. Okay, before running of the algorithm. So what people do some static and dynamic. People know based on their experience that if there is a process of type OS or if it is a type of user process or operating system process, they know about their past time. Okay, so based on that, they schedule them. Okay. Apart from that, this is a static kind of method, and so I have already told you here. So these are the things. I think you have missed it. So this is a static kind of thing, and for dynamic, so there are dynamic averaging. Okay, yeah, so for dynamic thing, we have exponential average or aging and simple average. So here I have also shown an example that if a process is coming, so you have already seen process T1, T2, T3, T4. So now for the next process T5, so you will calculate the bus time of the T5 like this. Okay. So your question is who will decide the bus time? So scheduler's job is to calculating the bus time. Okay. So here the answer is so at P0. Oh, okay. P1 is arrived. So P1. Okay. So P1 will run for 0 to 1. Okay. So at 1 you see. So here you have to check for each and every time instance. Okay. So at t is equal to 1, you will see that already P2 has also arrived. So at t is equal to 1, if you run for one instance, so you are left with 5 time instance for p1, and you have a lower and p2 has a lower bus time. So at t is equal to 1, we will run p2 here. So I was saying that this is a preemptive one. So hi Hanuman, your answer is wrong. Please check again what will be the answer. Yeah. So okay, at p2, so p2 will come at time instance 1, then it will run for one time instance. Okay, t is equal to 2. Then at t is equal to 2, p3 will come. But you see, uh, at t is equal to 1, at t is equal to 1, sorry, t is equal to 2, p2 is left with one time instance, and p3, which has just arrived, it is with 8 time instance. So it will not be it will p2 will not preempt. So p2 will run for 3 and p2 will finish. Okay, fine. Now at time is equal to 3, p4 has also arrived. Now what you are left with? You are left with 3, 8 and 5. So among 3, 8 and 5, which one is the lowest one? So lowest one is the 3. Okay, so you will run p4, which is for 3 times 2, which is 6 by, and then you will run, so it is finished. Then you will run p1 between 5 and 8. 5 is lower, p1 will be run for, then p, p3 p3 is remaining, p3 will be for 19, right? So what is the completion time of p1? So here you can see p1 has here p1 is for, you can see p1 for 2 times. In the previous all example you have seen only for 1 time. Yeah. So ct of p1 is equal to 11, then ct of p2 is equal to 3, p3 is equal to 19, and for p4 it is 6. So T80 is equal to CT minus 80, 11 minus 0, 3 minus 1, 2, 19 minus 2, 17, 6 minus 2, 3. Waiting time is equal to T80 minus BT, which is 11 minus 6, which is 5, 2 minus 2, 0, 17 minus 8, 9, 3 minus 3, 0. Okay, so our waiting time is equal to 9, 9 plus 5, which is 14 by number of process. So 14 by 4, which is 3.5. Right? Yeah. Ishant, you are absolutely correct. Yeah. Okay. So, okay. Yes. So now concept is it is time 3.5. Okay. Now here we also have process number. We have to find the P1, P2, P3, P4, P2, 0, 1. Okay, now find the average waiting time. So your question is clear. Question is determine the average wait time. So this is your question. And what is the algorithm you have to use? You have to use the round robin scheduling algorithm. So you have already learned in the class. So can you please tell me what will be the answer for this? Okay, so let us check about that. Okay, so first thing is let us see some basic concepts on the uh, mm, round robin algorithm. So we have never talked about the round robin algorithm. So we have ready state now. mm, Past time less than. So in the question you have seen one thing, which is one thing is given, which is time quantum. So we have so time quantum is basically denoted by TQ. Okay, now so time quantum is given like 2 millisecond or 2 second. Okay, so if so you are in a ready state, you select a process. Okay, if your bus time is less than the time quantum, then yes and no. So if your bus time is less than time quantum, then execute till completion, or then it will terminate. Okay, now fine. So this is the thing. Now how we are doing? So you have a process. So it is in, if it is in ready state. Okay. So then you will, what you will do? So you will select the process. Okay. You will select the process. Okay. Now it will check the condition that BT less than TQ or not. Okay. So if that is yes, then it will go to the, it will execute till completion. Fine. Now, if it is no, then execute for that time quantum. Okay, the time quantum will be given. Then, after the execution of the time quantum, so if the TQ expires, time after the time quantum expires. Suppose you are running for two time quantum, but your bus time is 4. So after the time expires, it will come to the process creation table. Okay. So after process creation table, it will go to the no state. Okay, so yeah, so this is the state basically. So right, like this will be fine. This is the thing. Okay, now what I'll do, that I will calculate how. So here I have to maintain two things. So one is one queue. So this is a queue and our Gantt chart. Okay, your queue and Gantt chart. Fine. So this is the thing. Okay. Now what we will do? So so at t is equal to 0, I'll start my execution. T is equal to 0. At t is equal to 0, I have p1 and my tq is 2. Okay, so I can run for t2, t is equal to 2. So bt less than tq. So here you can see that I have to check bt less than tq or not. Okay, so this is my question. So you know here bt less than tq or not. If this is yes, then fine. Then if no, then fine. So here our condition bt less than is equal to not is equal to tq, because 6, our bus time is 6, so this is not is equal to 2 tq. So the condition is false. Okay, so we will run it for 2 time quantum. So in your queue you have process 1. Okay, so you have run it for 2 time quantum. So how many time you have left? You have left for 4. Okay, so at t is equal to 2, which processes has already arrived? You can see at t is equal to 2, P2 and P3 has arrived. You can see here. So you put them in the queue. Okay, so this is a queue. Queue, you know that from entry will be here, exit will be here. Okay, this is the entry and this is the exit. Fine. Okay, now at P1, so P1 is done. So after P2 and P3, P1 will come again here. Fine. Now you have P2 to run. So if you run P2, so P2, the bus time is 2 and your time quantum is also 2. So you will run for 4. Now, so P2 is completed. Fine. So now in the time quantum 4, who has arrived? P4 is already arrived. So you P4 is here now. Okay. Now which which one is next? P3 is next. So you have written P3. So run, how many time you will run P3? P3 will be run for 2 time instance. So like 6 and it will be 8 minus 2, 6. Okay. Now, so P3 is done. P3 is done. Now P3 will come here. Okay. So from this entry point, right? So now we will have P1 again. So P1 will run for 2 time instance. So it will be 4 minus 50. Then P1 will come again here. Now who's done? P4's done. So P4 will come here. So P4 will run for 2 time instance. Then 1 is left now. So P4 is here now. Now P3 is here. P3 will run for 2 time instance, which is 4, 12. So P3 will come here again. Now P1, for P1, it will run fully, nothing is left. Now P4 will run for 1 time instance, which is 15. It is done. Now 1 is left, P3, which is 15 plus 4, which is 19. Okay, right? So your what is your completion time? Completion time of P3 is 19. Completion time of P4 is, so you just see, look from here to here, right? 19, P4 15, for P3 it is, so P3 is done. P1 is 14, for P2 it is 24. P2 it is 4. Okay, P2 it is 4. Okay, fine. Now what is the turnaround time? Turnaround time CT minus 18. 14 minus 0, 14. 4 minus 1, 3. 19 minus 2, 17. 15 minus 3, 12. Waiting time is TAT minus VT, which is 14 minus 6, 8. 3 minus 2, 1. 17 minus 8, 9. And 12 minus 3, which is 9. Okay, 9197. Mhm. So can anyone tell me, am I doing anything wrong here? Hmm, I have done something wrong here. So P3 is 19, P1 15, P4 13, P4 13, P4 13, P4 9, 7, 50, 7, 3. Oh, sorry. Hold. Yes, yes. Diksha, I did it wrong. Sorry. Yeah. So I think now it is fine. So this is P4 basically. Okay. Now please try to answer these questions. You can write the C. So for the priority scheduling algorithm, it does not suffer from starvation problem. Yes, it is right. It is correct answer. So can you tell me that how many priority scheduling algorithms are there? So basically, there are two types of priority scheduling algorithms. Mm. So what's the difference here? So here you have we have already seen the example. Say we have process number. So along with the process, we will be given the priority. Priority. Then you have all the things ATBT, CTT, ATWT, all the things. Okay, right? So I have seen in the notes that this is not given anywhere, like where the priority will be given. Right. So like you have P1, P2, P3, P4. Then priority is like so this is like low priority 2, then 6, then 10, then 9. Okay. And so this is the highest priority. So this will be the thing. Okay. Then you have 0, 1, 2, 3, then 7, 10, 12, 3, like this. So this will be your table look like, and what you will do based on your Gantt chart. So you will first at time instance 0, which has come, 0 has arrived. So it has so it will it will execute for one time instance. Okay. Then what will done? What in the So it will run for 7. So within 7 you can see that all has arrived. Then P3 will run because P3 has the highest priority. So it will run for 12. So 7 plus 12, 19. Got it? Then P4, then P2. Okay. So these are the scenario basically for your priority scheduling algorithm. Okay. So it doesn't suffer from, so which is false for the priority scheduling algorithm. So if you can see that if also for the for for if the bus time here is like maybe one only, okay, only it only needs one time instance, but as this has very low priority, so this process will come at the end. Okay. Oh, sorry. So I have some mute. I have told so many things. Yeah, I don't know how it happened. Okay, so I was talking about the hmm, I have talking about the priority scheduling, which is preemptive, and which another is non-preemptive. So preemptive means that, okay, so one higher priority process has arrived. So if you already have another higher priority process, then you will not use it. So you will just you will let them hold and run another processes. So in here, what is happening that in a time t is equal to 1, t is equal to 0, t1 has arrived. So you run it for 7 time instance because it is non-preemptive. It is of type non-preemptive. Okay, so you are running for seven times. Then in within seven time instance, all p2, p3, p4 has arrived. So how long you will run it? You will run it for, so among all of them only, among all of them, see here that p3 has the highest priority. So p3 is 19. Okay, for 19 up to because past time is 12, so 7 plus 12, which was 19. So P3 will run up to 19 times. So you are seeing the effect of the extra column here, which is the priority. So this column is a extra one. Okay, and we are seeing the effect of this, that as this has the highest priority, so we are scheduling it fast. Okay, so also if P2 is of only one time quantum, if P2 has only 1 unit of bus time, but because of this column, because of this priority and all, okay, P2 has to wait very long. Got it? So that's why that's why this algorithm, priority scheduling algorithm, suffers from the starvation problem. Okay, so here it is saying that which statement is false. So this statement is false. So it says that it doesn't suffer, but it suffer from the starvation problem. And all rest of are true, like it may be preemptive and non-preemptive. I'm showing you that it is preemptive and non-preemptive time. It suffer from starvation problem. Yes, it is right, it is right. Equal priority process are scheduled in FCFS order. Yes, so you have two processes which have same priority. You will be scheduling in first come first serve basis. CPU is allocated to the process with the highest priority. Yes, that is also right. Okay. The option is E, all of them. So first come first serve scheduling is non-preemptive. So this is a long, yeah. So convoy effect. Convoy effect, you know that if suppose you are running algorithm, so here you have P4, and so this P4 is running for maybe its burst time is like 1000. Okay, so because of this P4 and this high burst time, all your process, if you have a queue, so all your process like P1, like P5, P6, P7, P8, all will be on hold. They are in a like, so you know that if one VIP is going, so another, so because of their convoy, all are all are affected. So that is why like this is called the convoy effect. Yeah. Shortage of algorithm suffers from this starvation problem. Yes, it is true. Shortage of algorithm can be either preemptive or non-preemptive. Yes, I have shown you that. wind algorithm. Yeah, right statement, right answer is none of them. Yeah, that's right. So this was the formula for aging, I think you remember. Okay, so yeah, the right answer is A. Now, which of the following is property of multi-level queue scheduling policy? Okay, yeah, the correct answer is true that multiple queues, priority assigned, preemption, fairness. Yeah. Okay, so the process are classified into different levels based on their priority, and then they put into the queues. Okay, multiple queues. Okay, and there is it's a preemptive algorithm. Okay, so another higher priority process. Hello, hello, please. Do you want to say anything? Hello, Vaishnavi, do you want to say anything? Vaishnavi, please mute yourself. Otherwise, okay. Yeah. So this is the thing that they can't diffuse it. So we have moved to our next chapter, which is the which you have seen in the lecture also. If you have followed the lecture, that process synchronization. So we will be seeing the detailed overview of this chapter in next lecture next week basically. Okay. So in this lecture we will be so there are like you have seen that if you have more than one process, how we'll synchronize it. So we'll be solving the question answers in today's class. So I'll be asking you to solve the questions, and in the next class, we will be covering all the topics of the that process synchronization in the next class. Okay, we'll be seeing about the what is the race condition and what is the critical section, all of this. Okay, so the question is for the producer consumer problem. What is the with unbounded buffer, the process that needed not wait to the process is that. Yeah. So can anybody give the answer to this question? Oh, Ishan, sorry, I didn't look at it. Your question is what is fairness in the last question? So what is the last question? Okay. Yeah, I was about to tell the about what is the fairness. Yeah. So because of some disturbance, I forgot. I'm sorry. I'm sorry. Yeah. So the thing is, multiple. Yeah. You know, we don't have any problem with multiple queues, priority assigned, preemption, fairness. Yeah. So what I was saying that yes, we have a multiple queues here. So we have multiple queues here like this. Yeah. So basically, if we get a process based on the priority, we put them in a queue. Okay, whenever this queue is done, we put them here. Whenever this is done, we put them here. Like this, basically, this happens. So, so here the question is, what is the which of the following is a property of multi-level queue scheduling? Okay, so you see here, so here only thing is that multi-level queue scheduling. So no one has said here that multi-level priority queue scheduling. Okay, so basically fairness is not always guaranteed in this multi-level queue scheduling. Especially when some queue, if this is the case that this is this is a high priority queue, so this is a high priority queue. This is a low priority queue. This is a medium priority queue. If this is the case, then fairness is not the situation. But here our question is only multi-level queue. Here no one has talked about the priority and all. So I am not assuming this. Okay. So we are just assuming that one process is entering from here, one process is entering from here, they will enter from here, then they will come here like this. Got it? Are you getting it? So this is only this will come from here, then here, then here like this. Okay, so they will enter from here, then exit from here. Okay, so this is the fairness thing. So fairness is basically you don't have to put all your, you don't have to fairly, you are fairly scheduling the processes. This is the thing. So there is no priority concern. But in real life, the queue is feedback queue is priority queue. So here the answer is A, producer. Okay. Next question is which of the following statement is true about the critical section? So a critical section is basically if a process is executing in the critical section, no other process are allowed to enter into the critical section, right? Okay. So suppose there is a P1. So that is, so I'll discuss this all this in the next class also. This is a critical section and this is a non-critical section. Okay, yeah. This is non, this is non. This is this like this. If it is the part of the program where shared resources are accessed by the process. Got it? Okay, Ishan, priorities are assigned for the real life scenario. In this question, oh, there is no one mentioned about the priorities and all, but the multi-level queue scheduling is the in if you we use the if you use the Linux operating system, so you can so you they use the multi-level feedback queue scheduling algorithm to process your thing. Okay, and for Windows and Mac I don't know basically, but in Windows system they have a dynamic kind of feedback queue and dynamic kind of shortest job fast algorithm they implemented in the Windows operating system. So these are the real life examples. Okay. The answer will be all of the above here. So multiple processes share the same data in critical section. This is what I am saying. A bound must exist on the number of time other processes are allowed to enter the critical section. Concurrent access shared data may result in the inconsistency. So multiple process access and manipulate the shared data concurrently, and outcome of the execution depends on the particular order in which access takes place is known as critical section or yeah, race condition. Right. So, okay. So use them as a definition. Okay, these are the definition basically. Definition of race condition. We'll see all of this in the next class also. Yeah. This is also a very important definition. Can anyone tell this? Okay. Okay. This is a definition of mutual exclusion. Okay, I'll come to this later. Later. So see first. Solve this question first. Yes, for 14, the answer is C. That is right. Both hardware and software level. Critical section problem can be solved, can be done in both hardware and software levels. Yes, the answer is C. Okay, so this was for our topic for today's lecture. So we will be We'll meet on next day. Okay. So, anything else? Can anyone want to discuss something else? Okay, I will upload the lecture. Mhm. So, are you able to access all the previous lectures? Like, okay, okay, fine, fine. Okay, okay. Thank you for joining. You can drop the call. Okay, thanks, thanks. And if you have any further question, you can ask me. Okay, thank you so much everyone for joining. We'll meet in the next week.